back all the way to the beginning of the course. What rule did we use for this one? Product rule, good job. Okay, so G of 2
is
negative
0.
1. No, G of 2 is negative 1.
It's negative 1.
Yeah.
G of 2, no.
G of 2 is 5.
Oh.
Oh, yeah.
Oh, that's graph of math.
If you take that and put 2, yeah, oh, it's 5
Oh,
plus
yeah, 5
0.
plus
It's
0.
kind of like this one here.
Oh, so it's what?
Yeah, though that part is 0, but then there's still a 5.
Yeah.
So this is 5. Derivative.
Oh, awesome. Isn't it supposed to be
Now G derivative of 2 is negative 1.
well,
Times
isn't it supposed to be G derivative 2 plus
G derivative 2 is
times
just
1?
equal to f of 2, so it's
Isn't
negative.
that
Yeah.
a product rule?
The product rule is u prime v
Oh.
plus v prime u. So now G derivative is the same thing as
F.
f. So
Negative 1, so
So
times
f of
2
2
is
times
negative
negative 1.
f of 2, what is this number here?
Negative 1.
Negative 1. So you get
Negative 2.
2 times.
3.
All right. We kind of did this one together, but do you guys have any questions? Any part of it that's confusing to you? Okay, I want you guys to know something. I did not just simply memorize that for this problem that G derivative was equal to F. Okay? You actually go to the function and you take its derivative. Now, it just so happens that the derivative of 5 is equal to what? 0. That's why it doesn't really have an impact and it still ends up looking the same way. G derivative is equal to F, alright? And it might be in your interest, in case you're getting confused by this, is the thing I worry about. You want to write down that that's actually a G derivative graph. Okay, so this whole time you're working with the derivative graph. Anyone get all of it correct? That's okay, alright? Yes?
How do you get 5 again for G of 2?
Okay, so G of 2 means you're gonna go all the way back to the G function, alright? And you're gonna put 2 in here. Now that's gonna read 5 plus the integration from 2 to 2. Well, there's no work you need to put into that. The area is just gonna be 0 for that piece, but there's still a 5 hanging around, okay? Any other questions? Yes, please.
I know that the graph is of G derivative.
Yeah.
But in the question, it doesn't say that. Like,
Yes, that's the whole purpose. You need to be able to look at that right there, Nadia, and say, okay, so if you're telling me that G of X is equal to 5 plus the integration from 2 to X f of t dt, this is one of the first things you do. As soon as you see this problem, before you even start with it, you say, well then G derivative of X must equal F. And then one thing that was not relevant in this problem, but you should always do, is that right there. So you have to have these pieces of information, and most of that question is gonna revolve around those 3 facts, okay? So notice how all of these questions were about that fact right there. This question was about that right there. This question was about this one over here. And this question kind of did a mix of everything, okay? So, okay, let's keep practicing and showing. This one, I only brought in one part of a problem, not the entire thing. You're gonna need the graph, please, into your notebook. This one's a little bit different to copy down. Now when you copy the graph, I want you to read the problem. Okay, the problem contains some important piece of information. We're not going to answer any questions until we don't make a note of that information that's provided to us. All right. Now, obviously, we can't do this geometrically, right? It's not possible. We can't. We don't have the geometry skills to, and no one does, to figure out the areas of these curves. So instead, read what's written there. Do they tell you an area from 0 to 1?
Yeah.
How many is it? 2. So go to this pocket right here and put a 2 into that spot. Think of that. What's the next one? Alright, so to us, that's actually a -6. You might as well write that in because it's a pretty common thing. When you're trying to get through it, you make these silly mistakes. Alright, next one. 10 and the last one is -15.
14.
-14. Okay, then it says there are horizontal tangents at 0.6, 1.6, 2.5, and 3.5. I think that, like most people could have said, yeah, this is gonna be a horizontal tangent here, here, and over here. But what they're telling you is we might ask you a question that requires for you to mention where something is, so we're letting you know where those are located. Okay, your job is to write down that question. To find the absolute minimum value of f, this is perhaps the most difficult question in the entire lesson, where you don't have an equation, so you're working off of just what's been provided to you. You're going to be finding the absolute minimum. Oh, by the way, this is a graph of what? It's an f derivative. I want you to compare that. See, every time I made a graph, I wrote down what was there. This was a graph of f called g derivative. The one yesterday, well, 2 days ago, was a graph of f g derivative. This, however, they're calling it the graph of f derivative, okay? So that's one issue for us. Now, it wants the absolute minimum of f. That's what they're looking for. All right? So unlike the previous 2 problems, so I've selected these problems to bring them in to present to you, obviously, all the different ways they tend to ask this. So unlike the last 2 problems where you had an equation to work off of, here you don't have an equation anymore. So you need to create it by yourself. And that's a really tough thing for most students in Calc AB to do. So I want you to write down that when the accumulation function is not given, we need to make one.
Awesome, why would you make an equation when can't you just look at the graph of f derivative and know that from low to high is the minimum? Or is it because they're asking?
They want the absolute, so that's implying that this is a candidates thing, right? So we need it, right? Alright, if they had said relative minimum on that, then yes, you can of course do what we've always learned to do with f derivative graphs, okay? Alright, so we need to make one. So here's how you make it, okay? Watch really carefully. So look in that problem again. Somewhere in that problem they gave you an initial condition. It's embedded in there somewhere. Okay, so write down f of 2 is equal to 5. You have it already. Alright, now watch really carefully. Alright? That means if you want to find a value of this function, so f of x, it's equal to the initial condition, so f of 2, added to the integration from 2 to x, f derivative of t dt. Okay guys, where did I just figure that one out from? No, it's not the second one. Yes, this is actually, this is the first FTC, but I labeled it differently for you guys. We call this what? The rewritten version. Great job. So this is the rewritten version of it, okay? So you need to make it on the fly. You gotta make it by yourself if they don't provide it to you, okay? All right, now I want you to go ahead and do the same thing. Okay, we've done 2 candidates tests today, so this is a 3rd candidates test that you're gonna do. And again, take a look at what the candidates are. They did give you an interval from 0 to 4. and start with the candidates test. Sorry, I'm gonna try to fit it into this space because I've run out of space today. What's our first candidate, by the way? 0. Good job. What do you guys get for the first one then?
5 plus 2 is 77. 5 minus? Oh, we switched it. 5
2
minus.
0, right? Yeah, but I didn't just switch it, we all need to switch it, right? So what do we get? 3.
Wait, you have to split.
Yes, because it's 2 to 0, you can't work with limits like that.
Oh.
What's the next candidate?
1.
Think about it carefully. You really need 1.
2. 0
Okay,
points.
why would you forego 1? Why would you not bother with 1? What is it about 1?
F derivative.
Right, why would you take what you would have called a relative maximum
Oh.
and suddenly it transformed itself into an absolute minimum, right? Good job, right? It doesn't make a whole lot of sense. So you avoid candidate, remember, we call them candidates, but if they're changing the question, then you don't need all the candidates. So throw the 1 out,
And the 3.
and good job, and the 3, otherwise you'll make way more work for yourself than you have to, alright? So you don't have to take every critical point. We took every critical point when they used to ask us just the general question. So now we don't need all of them. Yes, Haya?
I just don't understand how varying from 0 to 2 is.
So the area from 0 to 2, oh, does that say 0 to 2? Okay. So that's 2 minus 6, which is going to give you -4. And so you put a -4 into that spot, so that gives you how much then? How much is it? 9. Thank you. Alright, so again, we're going to throw 1 out, we're going to throw 3 out, these are unnecessary, we'll go to 2. For the 3rd time today,
It's gonna be 5 plus 2.
right, that just becomes 2 to 2. So don't put a whole lot of thought into that. That's just gonna become a 5. So already we have a lower value, sorry, a minimum of 5. What's the final candidate that we need
4.
today? Alright, so 4. Let's see if I can fit it into this little space here. Yeah. In my wish list for the new school, I asked for a motorized board where I press a trigger and then the board goes up and a new board comes down.
Really? You asked for that?
Yes, Mr. Clark made fun of me extensively for it, but I hope I get it.
We have bidets in the new school.
It's for the benefit of the people, alright, it's not for me. Okay, so
This is my opinion.
from 2 to 4, what's the area from 2 to 4? -4, so 5 add -4. Make sure you make a concluding statement about what the absolute minimum is, that says justify your answer. So this is the work, but you have to write a statement that just kind of says the same thing. Yes?
Is the explain your reasoning when they ask for like a theorem?
No, it's the other way around. Justify generally is a theorem or something that's major. This is the candidates. By the way, you guys, It's not a bad idea to write down that you're using the candidates test when you do these things. Okay, it's a good idea there. Okay, did you have a question? Oh, okay. Any questions? Anything you're not understanding here? Yes. Again, I wrote down a couple of these for you earlier, so I kind of dodged writing it again here and over here because of space issues. Any other questions that you guys have? Yes.
Why did you say you skipped the checking the two?
That's a great question. Okay,
one.
now how about this? Let's take a look at this graph, okay? If you were to read this, Ode, as a derivative graph, which is what it is, notice that on this derivative graph, you would have marked at the 1, at the 2, at the 3, and then the 4 is the ending. You would have said positive, negative, positive, negative. Are you with me?
Yep.
Now you would have said that that means there must be a relative max at 1, there must be a relative min at 2, there must be a relative max again at 3, and then 4 we don't care about. Cool? Now give it some thought. If the question says absolute min, why would you entertain the maximums as candidates? It doesn't really make a whole lot of sense. So that's what Hadis was saying, okay? Of course, if they ask for absolute extrema, then you need to like have a much larger chart than this. This chart is too small, okay?
There's no space on the board.
There's no space on the boards. Yeah, that's true. And that's okay, right guys? We're gonna have a new school one day, as Sister Reem says. We're all gonna be happy. Why are you guys packing up?
Oh.
Yeah, come on now. Sorry, you guys look for every excuse to stop working. Okay. So, here's one last question, but this one's multiple choice, so don't worry, you don't have to do a whole lot of work. Technically it's on the calculator portion, but you know, that doesn't do much for us. The question says, we're giving you the graph of f derivative. And what we want is the value of x at which the absolute minimum of f occurs. This is technically a candidate's test. It's an absolute extreme question. So give it some thought. Don't blurt out any answers. All right. Talk to your friend.
It's not because it can't be one to the max, and 0 is for the endpoint. 0. I'm going up.
Because it increases.
2 is coming out. Wait, what is the
A
value?
lot, so it's like you have to do it more than 0.
And so there's a.
Okay, question number 1. You guys, have they given us an accumulation? No, they haven't. Okay, so the first thought that should go up in your head is I don't have a function. That's why I wrote it for you explicitly. So you should make one for yourself. But there is an issue here. They are lacking something. What did they not give us? They haven't given us an initial condition, meaning it shouldn't matter at this point because you keep adding that same number to all of them. So you're gonna throw that idea out because they don't want the absolute minimum. They actually just want where it occurs. You understand? So even though there should be an initial condition, I don't really know what that is. So I'm gonna just kind of forego that. And instead what I'm gonna do is I'm going to start from 0 because that's all I have. And I'm gonna go up until some value on this derivative graph, okay? So go ahead and tell me, what are the candidates that are important here?
0, 2.
Okay, so we should have 0 in the picture. We should have, okay, so why didn't you say 1?
It's
So it's a
a
max.
max.
Get it? So it's a relative max, so you don't consider it. So you just have 2 in the picture. Now, what kind of area are we looking at here?
Positive.
Positive, and notice how they purposefully made this, like, you know, it's significantly more negative than not positive. So when you go ahead and you start with it, again, you don't really know what this is,
That's zero.
but this is gonna, good job, this is gonna have to be 0, right? So you're comparing 0 against something else.
Opposite negative number.
Yes, and then let's go to the next one. Again, I don't know what the initial condition is, but think about from 0 to 2, it's gotta be a, good job, it's gotta be some negative amount, right? You pick up more negative than you pick up positive. And so in that scenario, what would end up happening is you know that that's where the absolute minimum must actually occur, all right? Before you wrap up, I have a question for you. Why do you think they put 0.5 and 1.5?
Because that's where the
Actual
actual
critical points of that.
Please don't fall for that, okay? This is not the graph of F, this is the graph of F derivative, so don't be. All right, great job, everyone.